Good day. This is Dr. Amrupriya, Associate Professor Triply from Rohini College of Engineering and Technology. We are going to deal with the course Power System Operation and Control, and in this lecture we will be seeing about the active power frequency control and reactive power voltage control. So first let us see about what is the term frequency and voltage defines. Let us consider a constant frequency which has to be maintained for many different reasons. First, all the AC motors should require a constant frequency supply so as to maintain constant speed. In the continuous process industry, this constant frequency, if it is not being maintained, it will affect the operation of the process itself. For synchronous operation of various units, absolutely constant frequency is necessary. And frequency, which this will affect the amount of power transmitted through the interconnecting lines. So frequency fluctuations are very harmful for electrical appliances as they would cause harmonics obviously. Speed of three-phase AC motors are directly proportional to the frequency. We know N is equal to 120 F by P. And also the blades of the turbines are designed to operate at a particular speed only. So frequency variation will lead to speed variation and this will cause mechanical vibration. Next, regarding constant voltage, obviously over voltage and under voltage are hectic problems to the electrical appliance operation. Electric motors will tend to run on over speed when they are fed with the higher voltages, resulting in vibration and mechanical damage. Also, over voltage will cause insulation failure. For a specific power rating, lower voltage results in more current and this will obviously create a I-square losses to a greater extent. And the kinetic energy which has been given by half JW square and N is equal to 120 F by P, they will be directly connected to the voltage levels. Now let us see about the ratio of active power to frequency control and what is the necessity of this control. Obviously, we know the load frequency control which is also known as the generation control or active power frequency control. It deals with the control of loading of the generating units for the system at normal frequency. The load in a power system is never constant and the system frequency remains at its nominal value only when there is a match between the active power generation and active power load. During the period of load change, the deviation from the nominal frequency, this may lead to a frequency error and it is an index of the mismatch and it can be used to send the appropriate command to the generation side by just by adjusting the LFC system. The LFC system can yes, that's an indication. It is basically controlling the opening of the inlet walls of the prime movers according to the loading condition of the system. In the case of a multi-area system, the LFC system also maintains the specified power interchanges between the participating areas. So in a smaller system, this control is done manually, while in a larger system, automatic control devices are used in the loop of the low frequency control. Next, while considering the reactive power voltage control, in this control, the terminal voltage of the generator is sensed and converted into proportionate DC signal and then compared to DC reference voltage. The error between them is taken as an input to the QV controller. A controller input of del Q is then applied to the exciter. So this is how the PF control and QV control will serve the electrical protectors system. And while seeing about the generation controllers, by these controllers, the active power is mainly dependent on the internal angle del and is independent of the bus voltage magnitude. The bus voltage is dependent on the machine excitation and hence on reactive power and is independent of the machine angle. Change in the machine angle is caused by momentary change in the generator speed and hence the frequency. Therefore, the load frequency and excitation voltage controls are non-interactive for small changes and can be modeled and analyzed independently. So, the thing is the load frequency and the excitation voltage regulators of a turbo generator can be schematically, it can be shown that how it is being affected and then we can see in the later figure. The objective of the megawatt frequency or the PF control mechanism is to exert the control of frequency and simultaneously the exchange of real power flows via interconnecting lines. Also, the objective of MVAR, that is a reactive voltage or QV control mechanism, is to exert the control of the voltage state. A voltage sensor senses the terminal voltage and converts it into an equivalent proportional DC voltage. This proportional DC voltage is compared to the reference voltage, and this error is being given as an input to the QV controller. Here we get transforms into reactive power signal, and this is then fed to the controllable excitation source. This results in the change in the rotor field current, which in turn modifies the generator terminal voltage. Thus, the entire control can be yielded by an automatic voltage regulator loop. You can see this is what is the diagram which I referred: automatic load frequency control and the automatic voltage regulator loop control. With these control actions, the generator turbine set can be perfectly operated as per the requirement. Thank you.